we can have a total of 3 such groups, which means that in one group we would have a total of 18 chickens, 20 ducks, and 24 sheep. And for the fourth way, we can have a total of 1 such group, which means that in one group we would have a total of 54 chickens, 60 ducks, and 72 sheep. Hence, the total number of ways would be 4. Question 5. We know that bus A comes every 12 minutes, bus B comes every 9 minutes, while bus C comes every 16 minutes. So let's compare bus A and bus B. Since the lowest common multiple of 9 and 12 is equals to 36, this means that bus A and B would meet every 36 minutes. However, 36 is not divisible by 16, so let's increase by another 36, which gives us 72. But 72 again is not divisible by 16, so let's increase by another 36, and this gives us 108. Again, 108 is not divisible by 16, so let's increase by another 36, which gives us 144, and this time 144 is divisible by 16. This means that all 3 buses would come at the same time in every 144 minutes. And 144 minutes is equals to 2 hours and 24 minutes. So, if all 3 buses came at 7:45 a.m., when would be the next time all 3 buses come at the same time? And the answer would be 7:45 a.m. plus 2 hours and 24 minutes, which gives us 10:09 a.m. Question 5. We know that Alan jogs every 2 days, Betty jogs every 3 days, and Colleen jogs every 4 days. Again, let's compare Alan and Betty. The lowest common multiple of 2 and 3 is equal to 6, which means that Alan and Betty would go jogging together every 6 days. However, 6 is not divisible by 4, so we try to increase by another 6, which gives us 12, and this time 12 is divisible by 4, which means that Alan, Betty, Colleen would jog together every 12 days. So within a 60 days period, what is the most number of days that they would go jogging on the same day? So on the 12th day, they would jog together. This is the first time they jog together. On the 24th day, which is another 12 days later, they would jog together the second time, and another 12 days later, which would be the 36th day, they would jog together the third time. And another 12 days later, which is the 48th day, they would jog together the 4th time. And another 12 days later, which would be the 60th day, they would jog together the 5th time. Therefore, the number of days that they would go jogging on the same day would be a total of 1, 2, 3, 4, 5 days. Question 6. We are supposed to find the smallest possible sum of P and Q. Because we are supposed to minimize the sum of P and Q, we can try minimizing P and minimizing Q. Because P is divisible by 4, 5, and 6, the smallest possible value of P, which is divisible by 4, 5, and 6, would be equals to 60. And the smallest possible value of Q, which is divisible by 6, 7, and 8, would be equals to 168. Therefore, the smallest possible sum of P and Q would be 60 plus 168, giving us a total of 228. Again, for question 7, we are supposed to find the smallest possible value of y minus x. Again, we can try by finding the smallest or minimizing y, and at the same time maximizing x. So, y is a multiple of 3. And we want y to be as small as possible. So the smallest possible value of y that is at least 63 would be equals to 63. And we know that x is a factor of 63, which means that x should not exceed 63. So the maximum possible value of x would be also equals to 63. Therefore, the smallest value of y minus x would be 63 minus 63, giving us 0.